Okay. First of all, আমি পড়েছিলাম হচ্ছে pressure or force measurement. কি করবে? Pressure or force goes into some transducer called load cell, and output will be electrical voltage or current or electrical signal. So what is load cell? A basic unit of transducer that can measure force or is a force sensor. So what are the inputs to a load cell? Load, weight, tension, compression, and pressure. And what will be the output? Electrical signal. That's the basic. Next is working principle of force or force transducer. What happens is, this is actually a load cell. There are zigzag elements made of metal. If you stretch this flame or pull it out, pull it or expand it, what will happen? This zigzag thing will start expanding. When this zigzag thing, the metal, the actual metal part of the load cell expands, its resistance increases. And measuring the resistance, these are the contacts. Connect a ohm meter here, you will get the resistance of the strain gauge. Resistance of the metal. When you pull it, resistance increases. When you compress it, resistance decreases. Since this thing works by pulling or compressing and measure a force, compressing force or expanding force, it is called strain. Compressing force or expanding force are called strain, that are stretching or compressing. To measure strain using resistance, so what you are doing is we are using strain gauge. So load cell basically consists of a strain gauge, and the strain gauge can be some metal, thin metal wire or metal foil. Since it is already thin, stretching or compressing can tear it. So you have to provide rigidity. In order to provide rigidity, this whole metal wire or this foil is bonded to something solid. That solid is a polyimide. Polyimide is like a plastic which allows stretching it or compressing it. And finally, the whole thing, that thing, the small thing which you have seen, the strain gauge. The strain gauge is mounted on this flexure. What is the spelling of this? ETCE. On this flexure, where here and here. So two strain gauges are kept. They are kept in opposite end. Why? If one gets stressed, the other gets strained. So they form the two arms of a Western bridge, and the other two arms are given a fixed resistance. When the bridge is balanced, the output will be zero. That is, no strain applied. So if force is zero or pressure is zero, then strain will be zero, and Western bridge will be balanced. তাহলে output voltage will be zero. But when force is not zero or pressure is not zero, there will be non-zero strain. That will cause strain gauges, the strain gauges to expand or contract depending on what you are trying to do. Are you trying to pull or are you trying to push in? The force is applied along the red. So what will happen as a result? The resistance of one of them will increase or decrease. causing Wheatstone bridge to be unbalanced. Once the Wheatstone bridge is unbalanced, output voltage is not equal to 0. So what will be the output voltage then? Output voltage will be proportional to the force or strain. That is the basic principle of strain gauge. But there is one more problem. The output of Wheatstone bridge the output voltage, basically output voltage of Wheatstone bridge is very, very low. So you need to amplify it. So you pass it through some amplifier and produce a good output, like high output voltage. This amplifier is a simple DC amplifier, which are responsive to not only DC but AC, like op amp or something. Or basically it is an instrumentation amplifier. We'll go into the detail in group B. Since the amplifier amplifies Wheatstone bridge signal, so it's called bridge amplifier. And what is the bridge made of? What are the main component of the bridge? Are resistance and two strain gauges. Therefore the amplifier is called strain gauge bridge amplifier. Why? Because the input is from a bridge and the bridge is designed using strain gauge. So strain gauge bridge amplifier. Another name is load cell signal conditioner. It is conditioning, or it is amplifying, it is filtering the received input signal. And since it is operating on the signal, so signal. And where is the signal coming from? Load cell. So that is how the name is given. The input is from load cell, the input is a signal, and the signal needs to be designed properly or filtered properly. That is called conditions. The amplifier have also will also have another purpose. That's generally normal amplifier don't serve this purpose. A Wheatstone bridge have a input or require an input voltage. These two are strain gauge and this is your output voltage, but your Wheatstone bridge will require some input voltage. That voltage is called excitation voltage. For any given configuration of this strain gauge, this Wheatstone bridge, if you increase the excitation voltage, your output voltage will increase. So there is another reading or normalized reading called MV per V. Before we come to that, the proper excitation voltage, or we can say the optima value of excitation voltage, is given by your that strain gauge bridge amplifier. Normal amplifier only amplifies the input, but the strain gauge bridge amplifier is like a feedback amplifier. It will also control this excitation voltage so that the output of transducer lies in a proper level. But what if you change the excitation voltage? The output voltage will also change. Generally, the output of Wheatstone bridge is in the order of millivolt. So increase voltage and don't change any condition of the Wheatstone bridge, your millivolt output will also increase. But if you are designing some system, like some standard system, say using microcontroller and all, you will require a normalized input. Normalized input means if nothing changes in your Wheatstone bridge, then output voltage will also remain fixed, even if your excitation voltage is changing. How that is done? It is done using a new unit called MV per V. That is millivolt per volt. what you do is your signal conditioner will output this value. Whatever be the excitation voltage, if your Wheatstone bridge, the condition of the Wheatstone bridge or the strains are not changed, the output millivolt per volt will always remain the same, even if the excitation voltage is changed. That is the responsibility of your load cell signal conditioner or strain gauge bridge amplifier. Your output voltage millivolt per volt will remain the same. This type of unit are obtained by your Wheatstone, by dividing your Wheatstone bridge output voltage by excitation voltage. This voltage will be considered as the actual normalized voltage output or actual normalized output of load cell. Then we come to another important concept called sensor accuracy. Sensor accuracy means what is the minimum change of strain that your load cell can detect. So if your strain changes by even a small amount, let's for instance 0.1 Newton strain, not 0.1 Newton, if your strain is 0.1, say something, 0.1 centimeter per meter change is detected, and another detect 0.01, then you can say the second one is much sensitive than the first one. So what are the advantages and disadvantages? The metal foil strain gauge, their advantages is high accuracy, they are reliable for long-term use, they are available in various shape and size, they are cost effective, the strain gauge is not affected by temperature, they are available in capacities which can measure from 10 grams to 100,000 pounds, that are around 5 ton. Then application will be high precision load cells are used in surgical robotics to aerospace, miniaturized force sensor, rolling element bearing, automatic bottle filling machines, seat belts of automatic crash system. Now I've discussed already your millivolt plus volt unit, type of strain gauge, that also I've discussed previously, the type of strain gauge. There are 7 types. Should I read the names? The type that are important to get the idea is unbonded strain gauge and bonded semiconductor strain gauges. Unbonded strain gauge have a diaphragm on which force is applied. They have wires. Two wires. When you don't apply strain, the wires will form there are 4 wires forming this Wheatstone bridge. When there is no strain, these 4 wires are balanced, the resistance are balanced, and output is 0. But when you apply some force on this diaphragm, 2 of this wire will be stressed, while like the 2 will experience a expanding force, and the other 2 will experience a contracting force. So for instance, these 2 will experience expanding force, say plus. These 2 will experience contracting force and will cause the Wheatstone bridge to become unbalanced, causing an output voltage to appear, which is proportional to force or pressure applied on this diaphragm. That is the basic principle. This system has a gauge factor of 2 to 4. Okay, the output will be typically in millivolt, 20 to 50 millivolt. The next is semiconductor strain gauge. Semiconductor strain gauge contains a piece of semiconductor on a substrate. or we call base. They are attached, this semiconductor is attached to the substrate using glue. These are contacts where you can measure your potential or measure the resistance. Let you attach a ohm meter here. Since semiconductor are highly affected, the resistance of a semiconductor is highly affected by strain. How? Resistance is proportional to resistivity. When you strain a semiconductor, its resistivity changes along with the length, and that will cause the resistance to go high. This is called piezo resistive effect. When you apply sufficient amount of strain, the resistivity of the material changes, and since you are also using compressive expansive stresses, its length changes. Correspondingly, the whole substance, like the whole semiconductor strain gauge, will exhibit a high change in resistance. And materials used as semiconductor, silicon and germanium, two material very important which are used. They are made using wafers, filaments, and bonding materials. Filaments are the semiconductor, the actual strain gauge. The wafers, these are for support and sturdiness, and bonding material for attaching them or attaching them to the subject of interest. Advantage of semiconductor strain gauge, they can be made to form an IC, and they can measure local strain. If a strain is distributed over a large area, it is not a local strain. But if it is distributed over a very small area, or the strain is concentrated in very small area, or the third option is you want to measure a strain in only a part of this large area. Like for instance, you want to measure strain only in this part. This is your interest part. Then you will call it local strain. So semiconductor strain gauge can measure local strain very accurately. Advantage, they have very high strain factor, like gauge factor. Gauge factor actually amplifies. If your input strain is, let's say, X, that you can multiply by gauge factor GF, and you will get your output strain X. So higher the gauge factor, the lower the strain can be, which you can measure. If your strain is in the level of micro, then it is called a micro strain. Using a semiconductor strain gauge whose strain gauge factor is around 130, you can see you can measure your micro strain. Hysteresis is very excellent. Even if there is no fatigue for this device. Like for instance, you keep on increasing the load. Even if you increase the load or decrease the load rapidly, your output, your strain versus output voltage will remain the same. It won't vary as you change the strain. Fatigue life is also very high. It is more than 10 to 10 into 10 to the power of 6 operations. You can utilize it for more than 10 million operations. Frequency response means how fast you can change the strain. Strain changes. It will be around 1 terahertz or 10 to the power of 12 times per second. They are also small in size, so you can make an IC out of it and measure local strain. Disadvantages: semiconductor strain gauge are very sensitive to change in temperature. They are almost non-linear, and they're very expensive. And the very big limitation is it's very hard to attach the semiconductor strain gauge to the object. You need good adhesive, and it will keep falling off if you don't attach it properly. That's all for today. So then tomorrow I will start a new topic. Not tomorrow, but next class I will start a new topic. That's it. Let's see. বাকিদের কার কি কোয়েশ্চেন আছে বলো। তো সবাই আবার চুপ করে গেল। বলো বলো কার কি কোয়েশ্চেন আছে। Okay, I hope that কারোর কোনো কোয়েশ্চেন নেই, so I'll stop the recording. Okay, recording stopped. এবার বলো কার কি কোয়েশ্চেন আছে।